affects revenue, it affects every part of the business. If you can forecast better, you're going to be in high demand. And what I was finding is that the methods that were being used to win some of these Kaggle competitions were often not what was being taught in academia.
dplyr allows you to pipe together a series of functions. It allows data processing to be so easy and clean and intuitive.
Modeltime Resample is designed for kind of like your back testing.
Matt, welcome to the program. It is an honor to have you on. How's it going in your part of the world?
Oh, it's going well. Thanks for having me. I really appreciate it, John.
Where are you calling in from today?
Sunny State College, Pennsylvania, and it's finally starting to warm up. So if you're on the East Coast, like near New York, about like 4 hours away from New York City. So
nice. 4 hours south, I guess.
It's almost directly west.
Oh yeah.
Yeah. You just take 80 to the west.
Pennsylvania kind of wraps around New York and New Jersey.
Mm-hmm.
Nice. Well, I haven't been there, but I'm sure it's lovely, and we are enjoying. It's starting to warm up here, so we're filming right at the end of March, and we're starting to get some nice sunny days. Getting shorts out, it's nice.
Yep, I've got my shorts on right now. I've been. I went for a walk today. I'm feeling good.
Great. So you've been on the episode twice before, but it's been a while. So I looked it up. You're on episode 109 in November 2017, and then 165 not long thereafter in June 2018. And I think it's safe to say that a lot has evolved since then, and I can't wait to fill in our listeners on it. We're delighted to have you back. And given your specialization in creating time series libraries for R, I think we should have an episode dedicated to the wondrous aspects of time series analysis.
Absolutely. And it's definitely something that's so helpful for companies. I used to do it all the time for my last company. And, it's something that I really want to be able to help other data scientists be able to learn how to do it for their companies. Because it literally affects revenue. It affects every part of the business. If you can forecast better, you're going to be in high demand. So.
Nice. Tell us how you got into developing time series libraries for R.
So there's been kind of probably the past like year and a half. I've been developing a series of time series packages that is forming a small ecosystem. It's kind of like a small army of R packages. And really the story behind it is I was actually developing a course January of last year, and I almost quit several times. It was a time series course because I was trying to use all of the existing system in R, and I was just having a heck of a time putting it together. I was number one, I was writing thousands and thousands of lines of code to be able to do simple things like to be able to visualize time series, to be able to clean the data, to be able to, come up with like engineered features. I was constantly having to go through and back and forth through different systems. Like one's called like XTS, one's called the Tidyverse.
That. It's been a while since I've been proficient in R, but I remember XTS. The Tidyverse was just starting to come along in kind of near the end of when I was using R a lot.
The Tidyverse has helped out a ton, and that's actually the system that I centralized on. So I said, all right. So the problem I was running into, you got 15 different time series packages that do different things. One does like anomalies, one does forecasting, one does sliding calculations, those types of things. They are all developed by like each, different people. So these people aren't talking to each other. They aren't standardizing on, hey, here's how you this function should operate this way. And then you can pipe it right into this function. No, there's none of that. So it ends up driving me nuts, to be honest. Like literally, I'm trying to put together this awesome course on teaching people how to do all the stuff that, I've been researching. And yeah, it wasn't going well. So that was the start of the ecosystem.
And I guess for the sake of our listeners, we should also mention that you create a lot of courses. So, I mean, that's how you're making a living these days, right? You
Yes.
run the business science platform.
Yes. Yeah. So I'm the founder and CEO of Business Science. To give you a little bit of background, I've been developing courses over the course of about 3 or 4 years now. I have about 2,000 students, and I focus on basically taking somebody who knows nothing about data science or has very limited experience with data science and getting them their careers accelerated as fast as possible by learning the most in-demand technologies, like time series being one of them, but also how to make web applications, how to use AWS, how to do like all the things that like no one ever teaches data scientists how to do.
The web applications, I guess, would be R Shiny.
Yeah, shiny web apps. I have two courses on that, an intro one, and then a like a developer slash advanced one. And then also the whole consulting, like the how do you take a organization, integrate data science into it? How do what frameworks do you use? How do you go from like A to B, and then build out a kind of like a large scale project with them? So I teach all of that stuff. It's all based on my real experience too. So like the time series stuff, that's all based on things I'm either actually doing at my current company, which is business science, or at previous companies or engagements that I've had. Obviously nothing proprietary, no proprietary data or anything. But the techniques are all solid. They're all the ones that
Yeah.
I've been using for past 7 or 8 years now. So
Yeah, so I guess business science then also does some consulting on top of the teaching.
we not really. We used to do consulting. Actually, business science used to be a consulting company for like the
Oh,
very, very first beginnings. But after about 6 months to a year, we quickly transitioned into education, and that was just basically I was seeing a ton of every company that I was working with. It was all like an education problem. They all had competent
right.
people that just didn't know how to apply data science to business. And that's really where I got the idea. All right, this is the real problem. This is the real market. This is what I need to be doing, is helping to educate the future workforce. So that's how I got into it.
Yeah, sounds hugely valuable. And I promise to you, listener, we're going to dig into time series analysis to an incredible amount of depth in a moment. But before we do that, I want to talk about R Shiny for a second again, because I don't think we have bigged it up enough yet. R Shiny is cool. So it allows you to very easily build your own web applications around some kind of, yeah, I mean, I don't know why you would use it if there wasn't some kind of data involved. I
Mhm.
think that's kind of like the main use case. You wouldn't make it to, I don't know, create a website for selling something, but it's for making web apps that have something to do with data. So you can imagine the same kinds of things you might use Tableau for, but it allows you to have way more customizability. You have a huge amount of control over the way that you're storing data in the back end, how you're calling it up, how you're visualizing it, and it all is rendered in HTML. And you can port it over to a server in like a couple lines of code, right?
Right. Yeah, our Studio Connect really makes it super easy now. It's just push button publishing of apps. So the our Shiny, that's honestly the first gigs that I got as a data science consultant. They weren't really even data sciencey. I wasn't doing a whole lot of machine learning. It was just people who wanted a way to take the data that they had and put it into some sort of application that didn't involve Excel and them having to open up a file. Just being able to pull it up on their through their web browser or Chrome. So fast forward now, though, Shiny, the ecosystem has evolved so much. It's insane. And, it's just so powerful. In fact, I've done a lot with integrating time series into Shiny apps. That's one of the things I built. I
Ooh.
built this app called I call it Nostradamus. but it's basically an automatic forecasting app that uses some of the time series packages that we'll talk about, Modeltime, Timetk under the hood, but in a user-friendly way where, somebody just clicks one button, builds like 28 or 30 plus models, ensembles them together, makes the forecast, makes visualizations so people understand what's going on, and it does it
Cool.
pretty quick. So our shiny.
Nostradamus.
Yeah.
Eliminating unnecessary distractions is one of the central principles of my lifestyle. As such, I only subscribe to a handful of email newsletters, those that provide a massive signal-to-noise ratio. One of the very few that meet my strict criterion is the Data Science Insider. If you weren't aware of it already, the Data Science Insider is a 100% free newsletter that the Super Data Science team creates and sends out every Friday. We pore over all of the news and identify the most important breakthroughs in the fields of data science, machine learning, and artificial intelligence. The top 5, simply 5 news items. The top 5 items are handpicked, the items that we're confident will be most relevant to your personal and professional growth. Each of the 5 articles is summarized into a standardized, easy-to-read format and then packed gently into a single email. This means that you don't have to go and read the whole article. You can read our summary and be up to speed on the latest and greatest data innovations in no time at all. That said, if any items do particularly tickle your fancy, then you can click through and read the full article. This is what I do. I skim the Data Science Insider newsletter every week. Those items that are relevant to me, I read the summary in full. And if that signals to me that I should be digging into the full original piece, for example to pore over figures, equations, code, or experimental methodology, I click through and dig deep. So, if you'd like to get the best signal-to-noise ratio out there in data science, machine learning, and AI news, subscribe to the Data Science Insider, which is completely free, no strings attached, at superdatascience.com/DSI. That's superdatascience.com/DSI. And now, let's return to our amazing episode. All right, so that's a great segue. So we can go from Nostradamus, your R Shiny app for making forecasts, to talk about the underlying time series models. You mentioned them there briefly. There are 1, 2, 3, 4, 5, 6 that we're going to talk about in turn. The 2 big ones that we need to talk about up front are Timetk and Modeltime. So Timetk allows you to prepare data for time series analysis, and then Modeltime is for applying machine learning on those time series data once they're properly formatted. So quickly trying out models. So tell us about why you created these libraries. And I mean, I've now pretty much said everything that I know about Timetk and Modeltime. So please fill us in with more detail on why they're so valuable.
Yeah, so let me start with so Timetk is where you do like the data wrangling and the visualization. The cool things, just at a high level. If I wanted to pitch you on why you should use Timetk versus whatever else you're using, one line of code it pretty much does everything. So if you want to plot something, you just use like plot time series, and we centralize on the data frame. So if you're comfortable with the tidyverse, all you do is you take your data frame, you pipe it into plot time series, and it spits out either an interactive visualization if you select interactive, or if you turn interactive to false, it produces a ggplot, a static plot. So either a plotly or a ggplot object. That's the plotting utilities. There's probably 6 or 7 plotting utilities, everything from anomaly detection to seasonalities, all the normal stuff, ACF, so you have autocorrelation and those sorts of things. That's just the plotting though. Then you have data wrangling. So there's all these these dplyr functions. So dplyr, that library has a function called summarize. You use it often like group by and then summarize.
I'm familiar with it, yeah.
Okay. Well, then you're immediately familiar with Timetk then, because instead of group by and summarize, it's group by and summarize by time. And you just tell it, what element, if you want to summarize it weekly or daily, and it
Ah,
automatically does all that stuff for you. So you don't have to. It speeds you up. It's a productivity booster, right? And then it has a lot of stuff for as you take your data science through the workflow. So you visualized it, you've wrangled it a little bit. Then you're getting it to a point where you want to do some forecasts. So there's all sorts of they're called pre-processing recipes. So this recipes thing is a big package that's being developed by the people at our studio.
mhm.
Uh, they call it the Tidy Models ecosystem. So recipes is a package in that ecosystem where you do pre-processing recipes. And I have a bunch of time series pre-processing recipes. The biggest one is the step time series signature. It's got a funky name to it, but that is the number one function you need to learn if you're getting ready to do some forecasting and feature engineering. And it creates like 30 time series features out of your timestamp. So things like day of the week, month of the year, it just automatically creates all that stuff for you. And then you can normally just run like your model right off of it. Big productivity booster.
Nice. Let's give a little bit of context on some of the items that you've mentioned. So, R Studio, huge commercial player in the R space, probably the biggest. They have created an IDE, a development environment for building and running R models, including R Shiny web apps, and it all functions very nicely. That's available for free, and I think I guess, they monetize by providing support, commercial support if you need it, helping you get things up on servers, that kind of thing.
Yeah. So our studio, they're actually getting pretty big into Python now too, to be honest. And I know that's probably just the data science market tends to be very heavily, a lot more typically Python users than R users. But I will tell you this, they have noticed that and they're kind of expanding the support. But their big thing is the RStudio IDE integrated development environment. That's where I learned to do data science, and
Mhm.
it's very nice, very user friendly. It's probably the best data science IDE out there, and I've tried them all: Jupyter Notebooks, Labs, VS Code. I'm creating a Python course right now with VS Code. Uh, you know, not. I mean, our studios just makes things so easy. They do. Um, Big commercial player. They also spend probably a good bit of their resources on developing open source. So they are without them,
Exactly.
R probably wouldn't exist. It would be all Python, to be
Mm.
honest. Um,
So
but
Hadley Wickham, big
Hadley Wickham
player over
works.
there.
Yeah, works
Yeah,
for our
he was a guest
studio.
on the Super Data Science podcast not too
Oh,
long
you
ago.
guys had Hadley. All right. Yeah,
Yeah.
Hadley's a
Um,
he's a personal friend of mine. Just small story about him. Back when I was first starting to attend some conferences back, when I first started business science, he actually reached out to me and we had lunch, at one of the conferences. And I mean, I couldn't believe I was starstruck the whole time because this guy, like literally, he's the person who developed dplyr, the
mhm, mhm,
and
mhm.
he also developed ggplot
Which
too. So
Yeah, which are we mentioned both of those, and so maybe we should talk about them quickly. So
yep,
dplyr allows you to pipe together a series of functions, like if you're familiar with piping things together in a Unix terminal. It allows data processing to be so easy and clean and intuitive in a way that prior to dplyr, you had to have either separate lines for each step in the process or really ugly nested parentheses
yes,
of functions.
yeah,
And so dplyr beautiful for that. And ggplot, gg is grammar of graphics, and so it's based on a book called Grammar of Graphics. And so Hadley Wickham used that book as the inspiration for coming up with a really comprehensive way of plotting ggplot.
yes. Yeah, and it's really those two packages alone. They're two of the most. They're definitely in the top 10 most downloaded packages, probably the top 3 or 5, which shows you how popular they are. But really, it's just a new wave of um, doing data science. He basically created a structure that makes it almost like writing a book. like writing a paragraph of text, hey, start with my data, group it on this particular category, select these columns, summarize this part of that data. And so it's all like, it's words. It's not like you don't feel like you're coding. You feel like you're writing down something. And then the ggplot syntax, he kind of, like you said, extended the grammar of graphics, but that, it's, the way I learned to plot. ggplot2, create a ggplot, add a, scatter plot, or add a smoother to it, and time series. I mean, it's wonderful. So
Nice. So Hadley Wickham, inventor of these brilliant R packages, he invites you out to lunch at a conference, and then
yeah, and I mean, this is a guy that he's basically the face of R, right? The programming language that I've grown to love. He invites me out to lunch. We have a great conversation. I got to learn a lot more, but he really just wanted to learn about what I was doing, and I just couldn't believe that somebody who's so prolific is willing to take time out of his day to sit down with me, little old me, who made one small R package that he saw and that he knew about. That package is called TidyQuant. That was my first that was a financial package. That package has actually now been downloaded, I think, around 600,000 times, 700,000 times. So it's grown too. But
what did it do? We're not going to stay on it too much, but
it's kind of related to time series, but it's more for financial analysis. It integrates some of the stuff that's out there, like the XTS, the Quant mod. It makes it tidy, so it ports that functionality over to the tidyverse.
Yeah. I guess we haven't mentioned this yet. For people that aren't aware of the tidyverse, the whole point of it, it's a collection of packages that makes data tidy.
Yes.
So a specific format makes it easy to read, makes it easy to work with other packages from the tidyverse.
Yes. Yeah, it's a whole ecosystem, and it's a movement too. I mean, it's really like people, you're either base R or you're tidyverse. And I'm more tidyverse because that's just kind of how I learned. dplyr came out right when I was starting to learn R, and that package kind of it changed me. It changed me as the whole way I thought about data. I was just like, yes, this is how data is meant to be. Cleaned.
I'm so old that when I learned R, none of these tidy things existed. But I can confidently say, having made the switch, that life is way better in the tidyverse than outside of it. So
yes,
you don't have to convince me. All right. So anyway, Hadley Wickham invites you out to lunch on the basis of your TidyQuant package. And, I guess that's the story.
And that's pretty much it. I mean, at the end of the day, he's a very popular guy. He's somebody who, I looked up to, and I still look up to. And he's just willing to take his time out of his day just to learn, take 30, 45 minutes and learn about what I'm doing and why I'm doing it. And that really, I think, it's that sense of community. If you look at the broader R community, that's kind of like a representation of what I love about it is that people are so willing to help you. They're so willing to, all you got to do is reach out. He reached out to me through Twitter, said, hey, what are you doing? DM me. So I messaged him and said, holy cow, you're Hadley Wickham. Thanks for reaching out. And he says, hey, yeah, let's do
holy
lunch.
Cow, you're Hadley Wickham. I don't know if you knew.
Yeah. I can't believe it. So I got pretty excited. I was actually out in San Francisco with getting ready for the event, and I was with some of my buddies, and I was like, I was actually at a pub, and I pretty much screamed. I'm like, holy crap, like my buddy or my buddies, you gotta get over here. Check out this. And they're like, who the heck is this guy? Like they're not data scientists, so they don't know.
Yeah.
But
I understand. That would be a big deal. Hadley Wickham, if you're listening, if you ever want to reach out to me, I will scream with delight. So just there you go. We've actually Hadley Wickham. I've seen him a few times. I saw him at a conference. It was the American Statistical Association, their main statistical conference. Like 80,000 people go or something
Oh,
crazy. It was at this
wow.
huge convention
That's
center in
huge.
Chicago.
Yep.
Um, and he was at an R Studio booth, and I was presenting a poster not too far away, and I saw him that he was standing at the R Studio booth, and we made eye contact. And I got too shy, and I just like walked away. And
Well, he's very friendly. And he's always willing
oh,
to
I'm sure.
chat some more. So
But I was just like, what am I going to say to a celebrity like that? It's like
yeah.
just and the other time he came and he spoke at a meetup in New York, the Open Statistical Programming meetup, and it was amazing. I can highly recommend, if you have the opportunity to see Hadley Wickham talk in person, or if you, even if you just want to look at some talks online, really great talk, amazing pacing, lots of interactivity with the audience. In terms of looking up to people in so many ways, productivity is a R package developer, software developer in general, but also his presenting skills. I mean, what can't he do?
Yes. Yeah. What always struck me is he just has a clear vision of like what the future should look like for, for R, and whether or not, he truly knows it. It's like a lot of that stuff seems to come to fruition, and it's crazy. I mean, he's a visionary. So, all right, but
All right. Yeah. All right.
we get
Enough
back
about
into
Hadley Wickham. We got to get back to time series analysis. So, anyway, so I guess we were talking about Timetk. What does Timetk stand for? What does the TK stand for?
It's toolkit. So time series toolkit. Yeah. And I like to keep my, my R packages, their names pretty short or pretty, pretty obvious. So included the time, so you get the sense of what it's used for, and then TK, to give it kind of the toolkit. So
Nice.
just
Okay.
like
And yeah.
oh, I was just
Go
gonna say,
ahead.
just like dplyr is like pliers. It's like data pliers. This is like time series toolkit.
Nice. And we've already talked about what it does a bit. So it allows us to prepare data for time series analysis, but also lots of other cool things. Visualization, which could be interactive or not, in Plotly or
ggplot.
ggplot. It would be non-interactive. Data wrangling, and also pre-processing recipes. That's where we got to. And then I completely sidetracked us with RStudio and Hadley Wickham and all that. But where you were probably wanting to go was to then talk about model time, which once you have your data prepared in Timetk, you can then put it into model time and actually apply machine learning on the time series data.
Yeah. So the fundamental principle around model time, and I spent about a year or so kind of developing the framework for it. And the reason is because as I was going through my course, I was doing a ton of research, and and what I was finding is that the methods that were being used to win some of these Kaggle competitions were often not what was being taught in academia, and it was certainly not what was being was necessarily available through some of the forecasting frameworks that I was that were already developed in R. So what ends up happening is that those forecasting competitions that I was reviewing, many of them on Kaggle and whatnot, they all developed around these problems that are pretty similar to what businesses are now facing, which is they've got a big time series data set. And this could be like, anything with a timestamp in it, but you've got lots of products, you've got lots of customers, you've got, just tons and tons of data. And the problem is that, everyone assumes just you've got a univariate data set and you're just going to do an ARIMA on it. Well, that doesn't solve this problem that businesses are facing where they've got thousands and thousands of customers or products. There's a scalability piece. And so I did a ton of research, and I found that like Kaggle competitions were the closest thing out there. And what was winning them was really two different methodologies. First one was related to machine learning. So basically utilizing machine learning algorithms to process not just one model for each kind of, product, but rather process all the products together and then develop a forecast based on all of the products at once. So you have one model for many time series. That's what I set out to do with Model Time, was to come up with a framework that made it easier to go from this machine learning side of forecasting and integrate that into a framework that allowed us to visualize, to walk us through kind of a best in class workflow where you actually test on out of sample data. A lot of these packages that were written in R kind of utilize these in sample metrics, and to me that's just like, that's not how it's done. That's not how you really you measure and test and get a true confidence about your forecast. You got to test on out of sample data, and you got to kind of walk through a solid, well, I call it best practices. I guess that's the right word for it, but basically a structured approach where you should test these models. Where Model Time came in was, I could develop one, algorithm or whatever, but really the strategies that were winning these competitions weren't just doing one algorithm. It was doing a bunch of different algorithms and just experimenting and rapidly trying to figure out, which algorithms they should include and which they shouldn't include, which should promise. And then the idea hit me. I'm like, oh my gosh, this is what we need in R, is a straightforward framework where it doesn't take a whole lot of code in order to be able to kind of run through all these different algorithms. And then I started getting ideas for like adding the algorithms together, ensembling, because that was ended up being, as I was doing more and more research, that was like a winning strategy,
For sure.
and so on. So that's what Model Time came to be. So it's really just a forecasting framework for enabling us to do machine learning models. Also, it does ARIMA and Profit, some of those other types of models. But like,
What is we should, for the audience, ARIMA, ARIMA, right? What does that stand
yes,
for?
yeah, it's autoregressive integrated moving average, and it's basically kind of like, think of it like a linear regression, but that uses only lags of your time series. So that's how that algorithm works. The problem with that is when you bundle it in a forecasting software, the it becomes a univariate analysis because it's got a time dependency, and you can't scale that up. But Model Time 050, which was just released yesterday on
Hmm.
CRAN, includes a recursive function that does autoregression, and it allows us to do basically the same technique that ARIMA does, but you can use any different algorithm. So you can use
Cool.
XGBoost, you can use GLMNet, which is an elastic net. You can use
Yeah.
anything. It's awesome. So yeah,
Cool.
a lot of best in class techniques, a lot of things that are built based on what the needs are and the demands are nowadays, and how forecasting is done. The other piece of it is, so we talked about machine learning. Deep learning is the other one from competitions. Deep
Hmm.
learning is a big deal. So mostly in business data, deep learning hasn't really made an impact. Time series is the one area though where deep learning is having a huge impact. The Wikipedia um, website forecasting challenge, deep learning won by like a mile. Also, the M4 competition, which is another big forecasting competition, deep learning ended up winning that. And then that's also where this newer algorithm called NBeats got some fame there. But yeah, so deep learning is the other thing that I started to integrate into Model Time.
And so you have a whole, so there are, in addition to Timetk for pre-processing and Model Time, the main library for applying machine learning on time series data, on top of that, there are 4 additional packages in the Model Time ecosystem.
Yep.
And so the one that I think you're going to want to talk about right now is Gluon, which uses deep learning, right? And so I'm really interested to hear about this. So in these time series competitions, what kinds of deep learning models are they using? Like recurrent neural networks?
Yes. Yeah. So basically, what they're doing are using variants of LSTMs, which is a recurrent neural network,
Mhm.
and what they're doing is, well, in the time series competitions, they're kind of building them from scratch. But there's a little company called AWS or Amazon, and they decided to take kind of like these these deep learning algorithms that normally take a lot of code to put together, and they started making kind of variations. So they have this system. Have you ever heard of MXNet?
Sure, of
Oh,
course.
okay. So MXNet's like one of the big three. We'll call them deep learning frameworks, but really
Yeah, it's. I mean, it's a.
it's
Well,
low
I guess it.
level.
Yeah, and it would depend. And then if you're saying that, then you're considering Keras not to be a separate library.
Right. TensorFlow is the other one, and then the
TensorFlow, Keras, and PyTorch
PyTorch.
are head and shoulders in terms of popularity. So I
Mhm.
do a talk maybe once a quarter at a conference
Okay.
on PyTorch versus TensorFlow, which should you be using?
Mhm.
And I do it. So every time I do that, I go and I look at Google search popularity for the big libraries, and it's crazy. TensorFlow, Keras, and PyTorch are like head and shoulders above MXNet, and then I guess like CNTK would be
Mhm.
something I throw in there as well.
Yes.
Um,
Yeah, MXNet really doesn't get a whole lot of usage, but I will say this: the Gluon TS is something that they've developed, which is PyTorch and some of these other and TensorFlow haven't really developed anything specific to time
cool,
series.
nice.
So I found out about Gluon TS, and what Gluon TS does is it integrates NBeats, which is one of the bigger algorithms that has shown some promise with forecasting competitions, and they have a deep AR, which is surprisingly good.
All
I
right,
have
all right. So first, spell the what's the deep?
so
I hadn't heard that.
okay, yeah. So N beats is
N beats,
okay.
right? Yeah,
So the letter N,
yeah,
so N like neural, and
yeah.
then beats. And I'll be honest, I don't remember what each of the letters stands for.
Yeah.
I'm sure it's something, but
It's
it's
N
like
N beats. Got it.
yeah, it's like an ensemble of deep learning LSTMs, and they've got some kind of nice special concoction that they've implemented, and they've termed it N beats. And then there's Deep AR. That's the other algorithm that Modeltime Gluon TS. So I have those two big ones. There's more algorithms in the Gluon TS package, but those are probably the two most popular. Uh, the in terms of results, so I have several consultants that are in my courses. I have a community where I actually have started getting pretty close with some of my students. The ones that show promise, I've kind of starting to groom some of them for software development. But the consultants that are in there that are using Deep AR for these heavy duty time series projects. And when I say heavy duty, I mean like 10,000 plus time series. They have to use like Azure, and they've got like cloud resources and compute and GPUs that they can put behind them. They're using my model time software and the linkages to Gluon TS, and they're having really good results there. They're having really good
Nice.
results with XGBoost. I mean, it depends on the time series, but like they're having some pretty good successes with some of these strategies, and they're the same strategies that are winning the Kaggle competitions. So
That is super cool. Can I take a quick second to try to summarize what you've been saying here, just to make sure I'm getting it right, which
yeah,
will probably help the listener too.
absolutely.
So NBeats and Deep AR, these are two approaches to building time series neural network models as a part of the Amazon Web Services AWS Gluon TS package. Okay,
Yes.
you're not. I'm getting head nods, so I'm on track. And also, so included within these deep learning time series approaches, we're typically using a variant of recurrent neural networks called LSTM. So we said LSTMs a few times, but I just want to spell out. Spell out is the opposite of what I want to say. I want to read out what LSTM stands for, which is long short term memory units. I don't know, the U doesn't get a letter.
Yeah. Yeah.
But LSTMs, they are a specialized kind of recurrent neural network that allows these neural networks to take information from many time steps back in a relatively efficient way. And so I don't know. I just wanted to read all that back to, in case a listener is listening who isn't aware of RNNs and LSTMs. And cool. I'm also glad that I understood all of the linkages there that you've been talking about.
Yeah. The cool thing about LSTMs is they're basically I read somewhere they're like an ARIMA on steroids, right? So an ARIMA kind of uses lags as your features. LSTMs do something similar where they're kind of just taking a look backwards in time and using that sequence to kind of decide how that path should look into the future. So they're just kind of like a sequence algorithm, but they do a really good job on time series. They also do pretty good job at predicting future text. I know they're
which is a time series.
Yeah,
which we don't call natural language processing time series analysis, but hugely similar. Whether we're talking about the sound of a voice or words on a page, they occur in a sequence, and so so RNNs are often very popular in that space as well.
Yep.
Okay, awesome. So so we've got Timetk for pre-processing data, model time for quickly trying out machine learning models, applying machine learning models to the time series data. The MT Gluon package that you made specifically allows us to apply deep learning models, including these super powerful Gluon TS provided approaches like NBeats and DeepAR. I'd love to talk about your MT Ensemble package next, because I know that ensembles are another great modeling technique for getting top results. So do you want to tell us quickly what an ensemble is and what the MT Ensemble package allows us to do?
Sure. So Modeltime Ensemble, basically what we're trying to do is figure out a way to combine different forecasts. So in terms of results, ensembling was used in the most recent M5 competition, which analyzed Walmart store sales. It was a hierarchical data set. What that means is that there's, a store has many products. They fall into different departments. They fall in, each store has multiple departments. So there's the different dependencies. The thing is that competition showcased was you don't just pick, like one algorithm and kind of run it. Or if you do pick one algorithm, you got to try it with different kind of in different situations, different features and whatnot. And then you average the results or you combine the results somehow. That's what Modeltime Ensemble does. It's nothing more in its simplest form. There's a one function called, I believe it's ensemble average. All it does is just takes, if you've got 5 different models, it just takes those 5 models and their predictions and just averages them for you. But what's cool about it is it handles all of that the stuff, the averaging process, managing the models. It handles all of that stuff beautifully for you. So you don't have to worry about thinking about like, oh, am I putting this into a tibble now? Am I gonna, do I have to write some code to summarize it? No, it takes care of it for you, and out pops a nice, pretty plot. So that's basically Modeltime Ensemble in a nutshell.
And then you also have, so to round out the last, so we've gone over 4 of your 6 Modeltime ecosystem packages. The remaining 2 are MT H2O, which integrates AutoML, another great way to get top performing results. Tell us a little bit about AutoML and how you implement it.
Sure. Okay. So H2O is this company out there that has this amazing algorithm called AutoML. And there's a lot of different, what it does is automated machine learning. And there's a lot of automated machine learning packages. You might have heard of like Tpod is one of them. There's even, I think like Google came out with its own AutoML, and that's more for like deep learning type of projects. What H2O does is it works really well on tabular data, meaning like spreadsheet style. You've got kind of like normal business data. Most of them come out of like a SQL database, so you're going to be in like a 2D structure. That's essentially how we forecast in model time. So what's cool is since they've already taken care of the automated part, all we have to do is integrate it as a backend. So it's actually pretty simple. We just take their algorithm and we add it as a new engine, so to speak, and we fit it into our framework. So once that happens, you can forecast with it. So you can actually forecast with automated machine learning. To give you a little bit of background about the nuts and bolts behind H2O's AutoML, what they do is they implement XGBoost, random forest. They implement Elastic Net, which is the GLM, and then deep learning as well. Now, the thing is that H2O is designed for high performance. It's actually written in Java code, which is very fast. And that's the nice thing about it, is that it's super scalable. So when we're talking about like 10,000 plus different time series and millions and millions and millions of rows, it's going to be able to handle it. And it can be run in the cloud. It doesn't need to be run on your computer. You just change your cluster and you point it to like your H2O cluster that's running in the cloud. So that's really the massive benefit that you get there is, productivity wise, it's automated, which is great. You just run it overnight, or you run it for 30 minutes or whatever. It comes up with some good models, and then it also does some sort of automated stacking too, which is an ensemble approach. And it gives us another back end that we can integrate into the model time system.
Beautiful. And so that leads us to the sixth and final package in the Modeltime ecosystem, which is MT, Modeltime Resample.
Yes.
I've been saying MT as short forms, but
it's fine. Modeltime Resample is designed for kind of like your back testing. So you basically, what you want to do in machine learning, not necessarily time series, we don't normally implement this resampling process, but with machine learning models, you're always doing like cross validation, right? You're always trying to say, okay, hey, I've done my 5-fold cross validation. On average, my RMSE is X, Y, or Z, some number. And that's what this kind of does now, is takes your time series and splits it up, and you don't lose track of that sequence, but it helps us kind of resample it and just kind of put it through a workflow where you're doing that same. It's not called 5-fold. It's actually a different technique, because you have to keep the samples all together. But it does what's called time series cross validation. And the goal is to understand, how stable your models are. Do they stand the test of time when you take different sections and predict like the next, 12 observations or 24 or whatever it is. So helps manage some of that stuff. But at the end of the day, it's about trying to give the tools. So not just the machine learning and the cool algorithms, but also give the tools to be able to make sure that your predictions are robust, that you're going to get good results, and you can be confident in those forecasts that you're making.
Yeah, which is hugely important, obviously of utmost importance if you were building like a financial prediction. But in any kinds of time series predictions, you're going to want to make sure that you're not overtrained to the training data that you have, overfit to the training data that you have, that your model is likely to perform well on data it hasn't seen before, like data in the future.
Right.
Amazing. Thank you so much, Matt, for this tour of the Modeltime ecosystem, as well as some backstory behind the evolution of it. This is a hugely useful set of R packages, and I hope to be able to get my hands on it to tackle a time series problem soon myself. One last question before I let you go. Do you have a book recommendation for us?
Yes. So the book that I would recommend, honestly, one of the more influential books that I've read is the Steve Jobs biography, and I think it's just cool. I've always been interested in entrepreneurship, and I've built my own data science business. I'm also looking at other businesses to build as well. And for anybody who's just interested or fascinated in technology, just understanding, how Steve kind of grew with Apple, even the pre-Apple days, understanding more about him. I view him as kind of like one of these entrepreneurs that like is a once in a lifetime entrepreneur. So it was a pretty impactful book for me. So that's my recommendation. Steve Jobs biography.
That's a great one. And if people want to stay in touch with you, if they want to follow you to learn about the latest in time series libraries, time series models, maybe even some R Shiny, what's going on with Hadley Wickham, how can they follow you and keep track of what you're doing?
So I'd recommend LinkedIn. Just reach out to me there. You can follow me on LinkedIn. It's just Matt Dancho. Also, I'm pretty active on Twitter too. So if you like just kind of staying in touch with getting the latest R tips, that's my big thing. I'm always tweeting about what I'm learning. You'll get that. My Twitter handle is at M, my initial, my last name Dancho, and then 84. And yeah. I mean, the time series course is also another way. If you really want to learn time series, definitely I would recommend checking out my high performance time series course. It's gotten rave reviews, and it's also been my fastest growing course just in the short span that it's been out. So
beautiful. I can't imagine how valuable that would be to check out. All right. Thank you so much, Matt. It's been a pleasure to have you on. I hope we will have you on the Super Data Science program again very soon.
Absolutely. It's been a pleasure. And thanks for having me, John. I hope to be back sometime. And until then, have a great day and keep on doing what you're doing.
Nice. Thanks, Matt. Catch you in a bit. Holy smokes, did I ever enjoy that conversation with Matt, and boy did I ever learn a lot about modern approaches to time series analysis. Wish I'd known everything we discussed today back when I was a trader at a hedge fund. In today's episode, we covered R Shiny for quickly creating web apps involving data presentation, the Timetk package for pre-processing data for time series analysis, the Modeltime package for quickly trying out machine learning models on your time series data, and the other packages in Matt's Modeltime ecosystem for cutting-edge approaches like long short-term memory units with AWS Gluon, ensembles of models, H2O.ai's AutoML, and backtesting models via resampling. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, and the URLs for Matt's LinkedIn profile and Twitter profile at superdatascience.com/463. That's superdatascience.com/463. If you enjoyed this episode, I'd of course greatly appreciate it if you left a review on your favorite podcasting app or on YouTube, where we have a high-fidelity smiley face-filled video version of this episode. I also encourage you to follow or tag me in a post on LinkedIn or Twitter, where my Twitter handle is @JohnCroneLearns, to let me know your thoughts on this episode. I'd love to respond to your comments or questions in public and get a conversation going. You're also welcome to add me on LinkedIn, but it might be a good idea to mention you were listening to the Super Data Science podcast so that I know you're not a random salesperson. A reminder that starting with episode 465 next week, we will begin releasing guest episodes on Tuesday mornings, New York time. Historically, we've released Wednesday evenings, but by releasing 36 hours earlier, we'll be giving you 2 more morning commutes in your week to enjoy the episode. I can't think of any downsides to this change, but I didn't want you to be caught off guard. All right, thanks to Ivana, Jaime, Mario, and JP on the Super Data Science team for managing and producing another incredible episode today. Keep on rocking it out there, folks, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.